over the next few lessons, we're going to look at some different rules that are going to make differentiating easier. The first one we look at, well, it's what's known as the chain rule. It goes under many names. It's the chain rule, implicit differentiation, rates of change. It's all basically the same idea. This is the formal definition of it, which I never use, but this is what it is. U is representing some function of x. So that's what it is. This is how I remember it. See, basically it's anarchy. The chain rule is anarchy. We bring down the power. Okay? So bring down the power. Then when you want to be savage. When you bring them down, you want to throw them to the ground because you're taking them over. So that's when you lower the power. So you bring them down, you lower them, so you put them there, and then you've got to put the boot in. Right? Now there's an old expression about, I don't know if you heard about it, having a bit of biff. You ever heard of that? Bit of biff? That's fighting. Well, biff, diff, it's similar. So that's the last bit. You put the boot in. So that's the chain rule. Anarchy. Bring down the power, throw them on the ground, put the boot in. Bang, that's how we do it. So, something like this, 2x plus 1 squared, which we saw yesterday, but we expanded the whole thing out. We now can save ourselves some time. So what does it mean? Bring down the power. Well, the power at the moment is 2. We're going to bring it down and put it to the front. But then at the same time, we lower the power. So it was a 2, we lower it to 1, and then we have to boot out the derivative. So 2x plus 1 is the function. We're going to kick the derivative out of there. So the derivative of 2x plus 1 is 2. Bang, gets pushed out. There it is, 2. Tidy it up. We get 4 outside of 2x plus 1. Now that is the answer we got yesterday. It's just factorised. The advantage of it is when you now get something like this, power of 7, we don't have to expand that out. I mean, that will take a little bit of time to write that all out. We can do it all in one hit by bringing down the power, lowering the power, diff the inside. So that's why I remember it like that, because basically I'm going to do what I say. So as I'm saying it, I'm writing it down. Bring down the power, okay, that goes to the front, lower it, power's down, diff the inside, I'll write the derivative down. 7 3s are 21. X squared minus 10 all cubed. Doesn't have to be a linear function in there, it could be any type of function. Bring down the power, 3, lower the power, 2, kick the derivative out of there, 2x. 3 times 2x is 6x. There's my answer. Now, just because there's a 5 out the front doesn't matter. When I bring down the power, I just multiply it by whatever is there. So bring down the power, that becomes 30. Lower the power, bang, 5. Diff the inside, so let's kick the derivative out of there, minus 2. So we get minus 64 minus 2x to the power of 5. This is another way of writing it. That's more in the form of what we call implicit differentiation. I want to find dy dx. It would be the same as finding dy dt times the t dx. The dt's, if you like, cancel. The advantage of this is if we have the equation written in terms of its parametrics rather than a Cartesian equation. This is something like this. You remember parametrics from a previous topic. So x is equal to 4t, y is equal to 2t squared. Now if I didn't use this idea, what I would have to do is make t the subject, probably the first one would make sense, and substitute it into the second one. Then I get y as a function of x, I can go and differentiate it. Well, this saves time because I just differentiate each of these with respect to t. So differentiate 4t, we get 4. Differentiate 2t squared, we get 4t. Now I combine them together because I want dy dx. Well, dy dx would be dy dt times the t dx. Dy dt we just worked out is 4t. The t dx, well again, it's a rate. A rate is a fraction. If I want the t dx, I'll just turn dx to t upside down. So 4t times a quarter, t. Alright, it's in terms of the parameter, just like the parametric equations, but that's our answer. If I wanted it in terms of x, easily enough done, because x is 4t, so t is x over 4, the derivative is x over 4. That'll do us for today. Today's rule, the chain rule. Anarchy.